everyone, welcome to my channel ECE Scholastic. I'm Jasmine. I welcome you all to the session 4 of discrete time signal processing. In today's session, we are going to solve Idft problems with 4 points and 8 points. Similarly, we will be seeing convolution using DFT and Idft. Let's start the session with a problem. The question is, the first 5 DFT coefficients of a sequence x of n are x of 0 is equal to 20, x of 1 is equal to 5 plus j2, x of 2 is equal to 0, x of 3 is equal to 0.2 plus j 0.4 and x of 4 is equal to 0. Determine the remaining coefficients. From the question, we could understand that the given sequence is an 8-point sequence. Since 5 values are given, we need to find the remaining 3 values, that is x of 5, x of 6 and x of 7. So how can we solve this problem? We know a property of DFT, right? So what is the property? By complex conjugate property of DFT, we know the formula x of k is equal to x star of n minus k. I'm going to apply the value of k as 1. What value I will get? X of 1 is equal to x star of n value is 8 minus k value is 1. So this is equal to x star of 7. Or in other words, we can say x of 7 is equal to x star of 1 or x conjugate of 1, right? If I apply the value of k as 2, what will happen? X of 2 is equal to x conjugate of 8 minus 2. This is equal to x star of 6. Or in other words, we can say x of 6 is equal to x star of 2. If I apply the value of k as 3, x of 3 is equal to x star of 8 minus 3, which is equal to x conjugate of 5. So we can write this as x of 5 is equal to x star of 3. Right. Now it is very easy for us to find the answers, correct? How can we find it? We know x of 7 is nothing but x conjugate of 1. So that is equal to, we know what is x of 1, right? What is x of 1? 5 plus j2 the whole conjugate. So that is equal to 5 minus j2, right? Similarly, x of 6 is equal to x star of 2. That is equal to, what is x star, x of 2? X of 2 is 0. So if we take conjugate of 0, then we will get the answer as 0. Similarly, x of 5 is equal to x conjugate of 3. This can be written as 0.2 plus j 0.4 the whole conjugate. This can be written as 0.2 minus j 0.4. Okay, so as a whole we can write the sequences. X of k is equal to x of 0 is 20, x of 1 is 5 plus j2, x of 2 is 0, x of 3 is 0.2 plus j 0.4, x of 4 is 0, x of 5 is 0.2 minus j 0.4 and x of 6 is 0, x of 7 is 5 minus j2. So we have calculated the remaining 3 values with the help of the first 4 values. That's all. Let's move on to the next problem. Determine the Idft of the sequence x of k is equal to 12 minus 4 plus j4 minus 4 minus 4 minus j4. So here we have 1, 2, 3 and 4 samples, right? So totally we are having 4 elements. So we can consider the value of n as 4. Okay. So what is given in the question? X of k is equal to 12, minus 4 plus j4, minus 4, minus 4 minus j4, right? So this is x of 0, this is x of 1, this is x of 2 and this is x of 3. In the question it is given us find the Idft of. So we know the formula for Idft, right? X of n is equal to 1 by n into summation k equal to 0 to n minus 1 x of k e power j 2 pi n k divided by capital N, where the value of n is from 0 to n minus 1. Now I am going to apply the value of n as 4. So my formula will change as to x of n is equal to 1 by 4 into summation k equal to 0 to 3 x of k e power j. If I apply the value of n as 4, I will get pi n k divided by 2 for n is equal to 0 to 3. Okay, now I am going to expand the summation. So my answer will be 1 by 4 into x of 0 plus x of 1 into e power j pi n divided by 2 plus x of 2 into e power j pi n. 2 and 2 will get cancelled, right? Plus x of 3 into e power j 3 pi n divided by 2. Correct? Now I am going to apply the values of x of 0, x of 1, x of 2 and x of 3 and also going to expand the exponential terms. So my formula will become x of n is equal to 1 by 4 into x of 0 my value is 12, 12 plus x of 1 my value is minus 4 plus j4 into cos pi n by 2 plus j sin pi n by 2 plus x of 2 my value is minus 4. So minus 4 into cos pi n plus j sin pi n. Correct. Now x of 3 the value is minus 4 minus j4. So plus minus 4 minus j4 into cos 3 pi n divided by 2 plus j sin 3 pi n divided by 2. Okay, where the value of n is from 0 to 3. Now I am going to take this as equation number 1. Now I am going to apply the values of n as 0 to 3. Okay, so first I am going to apply the value of n as 0. My expression will change as to x of 0 is equal to 1 by 4 into 12 plus minus 4 plus j4. Cos 0 is 1 and sin 0 is 0. So it is 1 minus 4 into cos 0 is 1, sin 0 is 0 plus minus 4 minus j4 into the same cos 0 is 1 and sin 0 is 0. Now I am going to expand this. This is equal to 1 by 4 into 12 minus 4 plus j4 minus 4 minus 4 minus j4. Correct. So this plus j4 and minus j4 will get cancel each other and I will get the value of x of n as x of n is equal to this 12 minus 4 minus 4 minus 4. So 12 minus 12 it is 0. So my x of n value is equal to 0. Right. In a similar way, I am going to apply the value of n as 1 in the first expression. So x of 1 is equal to 1 by 4 into 12 plus minus 4 plus j4 into cos pi by 2 plus j sin pi by 2 minus 4 cos pi plus j sin pi plus minus 4 minus j4 into cos 3 pi by 2 plus j sin 3 pi by 2. Okay. Now I will get the answers as 1 by 4 12 plus minus 4 plus j4 into cos pi by 2 the value is 0 plus into j. Correct. So 0 plus j is j minus 4 cos pi the value is minus 1 where sin pi is 0 plus minus 4 minus j4 into cos 3 pi by 2 the value is 0 and sin 3 pi by 2 the value is minus 1. So it is minus j. Okay. Now I am going to expand this. So that is 12 minus 4j minus 4 plus 4j minus 4. Correct. So this is equal to plus 4j plus 4j plus 4 minus 4. So I will get the answer as 1 by 4 into 8, that is x of 1 is equal to 2. Now I am going to apply the value of n as 2. Therefore I will get the expression as x of 2 is equal to 1 by 4 into 12 plus minus 4 plus j4 cos pi plus j sin pi minus 4 into cos 2 pi plus j sin 2 pi plus minus 4 minus j4 into cos 3 pi plus j sin 3 pi. As you know, sin n pi is equal to 0. So I am neglecting all the sin terms. 1 by 4 into 12 cos pi the value is minus 1. So I will just multiply this. That is plus 4 minus j4 and cos 2 pi the value is 1. So minus 4 into 1 is minus 4. Sin 3 pi is 0 and cos 3 pi the value is minus 1. I'm just multiplying this, so plus 4 plus j4. Okay, so this implies the value of x of 2 is equal to minus j4 plus 4 minus 4. So that is 1 by 4 into 16, that is equal to 4. X of 2 value is 4. I'm going to apply the value of n as 3. On applying the value of n as 3, you can find x of 3 value is 6. You can do this by yourself. So as a whole, I can say x of n, the values are 0, 2, 4, 6. So this is how we will be performing the IDFT for a 4-point sequence. Okay. Next question is, determine the IDFT of the sequence x of k is equal to 5, 0, 1 minus j, 0, 1, 0, 1 plus j, 0. So here 1, 2, 3, 4, 5, 6, 7, 8. We can see that n is equal to 8, right? By the formula of IDFT, we know x of n is equal to 1 by n, summation k is equal to 0 to n minus 1, x of k e power plus j2 pi n k divided by capital N, where the value of n is from 0 to n minus 1. All these steps we know. Now I am going to apply the value of n as 8 in the formula. I will get the answer as x of n is equal to 1 by 8 into summation k equal to 0 to 7, x of k e power j. When I apply the value of n as 8, I will get pi nk divided by 4, where n is from 0 to 7. Right. I am going to expand the summation. So my answer will be x of n is equal to 1 by 8 into x of 0 plus x of 1 into e power j pi n divided by 4 plus x of 2 into e power j pi n divided by 2 plus x of 3 into e power j 3 pi n divided by 4 plus x of 4 into e power j pi n plus x of 5 into e power j 5 pi n divided by 4 plus x of 6 into e power j 3 pi n by 2 plus x of 7 into e power j 7 pi n divided by 2. Let's check this. So this is 0, this is 1, this is 2, this is 3, 4, 5, this is 6 and this is 7. Now we know x of 1 the value is 0. So I am neglecting this term, and x of 3 the value is 0. I am neglecting this term, and x of 5 the value is 0. I am neglecting this term, and x of 7 value is 0. I am neglecting this term. Now I am going to apply the values of all the remaining functions of x, and I am going to expand the exponential function also. So my answer will be x of n is equal to 1 by 8 into x of 0 the value is 5 and x of 2 the value is 1 minus j. So 1 minus j into cos pi n by 2 plus j sin pi n divided by 2, and x of 4 the value is 1. So cos pi n plus j sin pi n, and x of 6 the value is 1 plus j. So 1 plus j into cos 3 pi n by 2 plus j sin 3 pi n by 2. Correct? Where the value of n is from 0 to 7. Understood? I am going to take this as equation number 1. We will be finding the values of x of n for various values of n. If I apply the value of n as 0, I will get the value of x of 0 as 1. If I apply the value of n as 1, I will get the value of x of 1 as 0.75. If I apply the value of n as 2, I will get the value of x of 2 as 0.5. For 3, x of 3 is equal to 0.25. For 4, x of 4 is equal to 1. For 5, x of 5 is equal to 0.75. For 6, x of 6 is equal to 0.5. and for 7, x of 7 is equal to 0.25. Okay, so as a final, I can write this x of n is equal to 1, 0.75, 0.5, 0.25, 1, 0.75, 0.5, 0.25. So this is how we calculate x of n. I am not explaining the steps here because in the previous session as well as in the previous problem we have seen how to solve this. Okay, so please refer those two videos for the explanation of steps. Now let's move on to the next part, that is steps to perform DFT and IDFT through circular and linear convolution. Here we will be finding the output sequence with the help of circular as well as the linear convolution. So let me tell you what are the steps to be followed in circular convolution, also in linear convolution. So first is circular convolution. What is the first step we will do when we are dealing with circular convolution? We will check whether the length of the two given sequences are same. Correct. If it is not same, then we will be performing zero padding. Okay. The second step is we will calculate DFT of x of n. So DFT of x of n will yield x of k. Similarly, DFT of h of n, or in other words, we can say if the sequence is x1 of n and x2 of n, we will find DFT of x1 of n as x1 of k and x2 of n as x2 of k. Okay. Once DFT is calculated, we will be moving for the third step, which is calculation of y of k, that is output. Correct. How will you find y of k? Y of k can be calculated using the formula y of k is equal to x of k into h of k. Just we will multiply the values obtained from x of k and h of k. The next step is we will be finding the output sequence y of n by taking inverse discrete Fourier transform of y of k. Finally, we will verify whether the obtained y of n is the correct one or not with the help of matrix method of circular convolution. The answers of y of n using IDFT and using matrix method of circular convolution are the same. We can say that the output is correct. Okay, so that's all about circular convolution. In linear convolution, we will have the same sets of steps. The only difference is the first point. So in linear convolution, what will be the first point? We will calculate the overall length of the output sequence using the formula n1 plus n2 minus 1. Okay. So once the output length is confirmed, we will go for the remaining step, which is same as that of the circular convolution. Now let's do a problem. Compute circular convolution and linear convolution of the following two sequences using DFT and IDFT, where x of n is 1, 2 and h of n is 2, 1. Here it is asked for two convolutions. One is circular convolution and the other one is linear convolution. Now let's start with circular convolution. So using circular convolution means first is we need to identify whether the lengths of the two sequences are equal, right? X of n is equal to 1, 2. Therefore, we can say the length n1 is equal to 2. And h of n sequence is 2, 1. Here also the length n2 is equal to 2. So from this we could understand that n1 is equal to n2 is equal to 2. Both are same. Therefore, the length of the output sequence yn is also 2. Understood. Now let's start solving the problem. So first step is over. What is the second step? We will be finding what is x of k and what is h of k using DFT formula. So we know the formula of DFT. What is the formula of DFT? X of k is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi nk divided by capital N, where k is equal to 0 to n minus 1. In a similar pattern, h of k is equal to summation n equal to 0 to n minus 1 h of n e power minus j 2 pi nk divided by capital N, where k is equal to 0 to n minus 1. Let's find what is x of k. Okay, so we know the formula and also we know the value of n is equal to 2. Therefore, n minus 1 is equal to 1. Correct. So the formula can be rewritten as x of k is equal to summation n equal to 0, 1. We have only two values. X of n into e power. When we apply the value of n as 2, what happens? It will cancel. Therefore, our formula will be minus j pi n k, where the value of k is from 0 to 1. So that is 0, 1. Okay. Now I am going to expand the summation. This is equal to x of 0 plus x of 1 into e power minus j pi n k. That is e power minus j pi n value is 1 k, where the value of k is from 0, 1. Now I am going to expand this by applying the values of x of 0 and x of 1 and also e power minus j pi k. Therefore, x of 0 the value is 1 and x of 2 the value is 2, where e power minus j pi k can be written as cos pi k minus j sin pi k. So this is my expression and the value of k is from 0, 1. I am going to take this as equation number 1. Now I am going to apply the value of k as 0. What will be my answer? X of 0 is equal to 1 plus 2. Therefore, the value is 3. Similarly, if I apply the value of k as 1, my answer will be x of 1 is equal to 1 plus 2 into cos pi. Cos pi, the value is minus 1. This is equal to minus 1. Therefore, we got the value of x of k as 3, minus 1. So, how can we find h of k? We know the formula. H of k is equal to summation n equal to 0, 1 h of n e power minus j pi n k, where the value of k is 0 and 1. Now I am going to expand the summation, that is h of 0 plus h of 1 into e power minus j pi k, where the value of k is 0 and 1. This is equal to h of 0. What is the value of h of 0? It is 2 and h of 1 is 1. So 2 plus cos pi k minus j sin pi k, where the value of k is 0 and 1. So this is my h of k expression. I am taking this as equation number 2. Now I am going to apply the value of k as 0. I will get the answer as h of k is equal to 2 plus 1. That is equal to 3. And also k is equal to 1. I will get h of k is equal to 2. And the value of cos pi is minus 1. So minus 1, this is equal to 1. So the value of h of k is equal to 3, 1. Now I have calculated what is x of k and what is h of k. Step 2 is over. We are going to step 3. What is step 3? Step 3 is to calculate y of k. How can you calculate y of k? Y of k is equal to x of k into h of k. Right. We know the value of x of k is 3, minus 1 and h of k is 3, 1. On multiplying these two, we will get the answer as 9, minus 1. So we have calculated y of k. Right. What is our next step? Next step is, our fourth step is to calculate y of n using Idft formula. Correct. We know the Idft formula as y of n is equal to 1 by n into summation k equal to 0 to n minus 1 y of k e power j 2 pi n k divided by capital N, where n is equal to 0 to n minus 1. Here the value of n is equal to 2. Therefore, I am rewriting this as 1 by 2 into summation k equal to 0, 1 y of k e power j pi n k, where the value of n is 0 and 1. Expanding this, I will get the answer as y of n is equal to 1 by 2 into y of 0 plus y of 1 into e power j pi n, where the value of n is 0 and 1. I am going to apply the value of y of 0, y of 1 and also expanding this. So I will get the answer as 1 by 2 into 9 minus 1 into cos pi n plus j sin pi n. Correct. Where the value of n is equal to 0 and 1 and y of n expression is this. Now I am going to apply the value of n as 0. So I will get y of 0 is equal to 1 by 2 into 9 cos 0 is 1. So it is 9 minus 1, that is equal to 4. And also n is equal to 1. Y of 1 is equal to 1 by 2 into 9 minus 1 into cos pi, the value is minus 1. So it is plus 1. This is equal to 5. So I got the output of y of n as 4, 5. Now I need to check whether this answer is correct or not. For that, I am going to the next step, that is performing matrix method using circular convolution. So y of n is equal to x of n star h of n. I know what is x of n and what is h of n. I am going to perform this matrix method. So first is x of n. I am going to apply the x of n values 1, 2 and 2, 1. Next is h of n. I am going to apply the h of n value. So this is equal to 4, 5. So y of n is equal to 4, 5, which is same as that of the previous expression. So we can say that the output we found out is correct. Okay. So that's all about circular convolution method. Now let's check on this linear convolution for the same problem. I will tell you the first part, the second part you need to solve it. X of n is 1, 2 and h of n is 2, 1. What is the first step? We need to find the length of the output sequence. Length of the output sequence is equal to n1 plus n2 minus 1. Correct. Here n1 is 2 and n2 is also 2. Therefore, 2 plus 2 minus 1 is equal to 3. So the length of the output sequence is 3. Next, what is our next step? We need to find what is x of k, right? So how will you find x of k? Using DFT formula. What is the DFT formula? Summation k equal to 0 to. Here the value of n is 3. So I will be taking n is equal to 3. So I will be taking k is equal to 0 to 3 minus 1. That is 2 x of n e power minus j 2 pi nk divided by 3 for n is equal to 0 to 2. In a similar way, h of k is equal to summation k equal to 0 to 2 h of n e power minus j 2 pi nk divided by 3 where n is equal to 0 to 2. Correct. So we will be finding what is x of k and also we will be finding what is h of k. Once x of k and h of k is calculated, we will be finding y of k. How will you find y of k? Just multiply this x of k and h of k. Once this is found out, we will be finding y of n using Idft formula of y of k. So after calculating y of n, we will verify the answer with matrix method of linear convolution. We know x of n is equal to 1, 2 and h of n is equal to 2, 1. Correct. I'm just going to perform matrix method. So this is x of n 1, 2 and this is h of n 2, 1. I'm going to multiply 2 into 1 is 2, 2 into 2 is 4, 1 into 1 is 1, 1 into 2 is 2. So just add. This implies y of n is equal to 2, add these two, 5, 2. So this is our final output. If you get the answer y of n is 2, 5, 2 using DFT and Idft method, you can say that you are getting the correct output. Okay. So that's all for today's session. Hope you have enjoyed. In the next session, I will be giving some basic 2-mark problems under DFT and Idft. Thank you so much. Have a great day.